At the end of this video, I will explain how the circuit works. First of all, let's build the lamp. Our aim here is to make a circuit that will turn the LED on automatically in dark. For that, we need a light sensor. So for the sensor, I have an LDR. It acts like a conductor when light falls on it, and acts like an insulator when there is no light. To observe this, let's connect an LDR and an LED in series and connect it to a suitable power supply. When light falls on the LDR, the LED turns on. And when there is no light, the LED turns off. But this is not what we want. We want the LED to turn on in dark. And for that, let's use a transistor. If you don't know how to use a transistor, then make sure to watch my transistor part 1 video first. Alright, first of all, what I gonna do is use an NPN type transistor as a switch, like this. Our load here is the 3 volt LED. We know that transistor requires base voltage of around positive 0.7 volts to act like a closed key. So let's connect base to the positive terminal in combination with a resistor such that base gets positive 0.7 volts. Therefore the LEDs are on. Now if I connect an LDR in the circuit like this, what will happen? When the LDR is in dark, the LDR acts like an insulator. Therefore no effect in the circuit takes place. And thus the LED is on when in dark. However, when light falls on the LDR, it acts like a conductor. In this point, when LDR was acting like an insulator, it was positive 0.7 volts. But when LDR acts like a conductor, voltage at this point almost drops to zero. You can confirm it by using Ohm's law. When LDR is acting like a conductor, resistance becomes almost 0 ohms. Therefore, voltage at this point equals current times resistance. Since resistance is 0, voltage also equals almost 0 volts in this point. So in dark, voltage in this point is positive 0.7 volts, and when light falls on the LDR, voltage in the point becomes almost 0 volts. We know that transistor acts like a closed key only when its base voltage is around positive 0.7 volts. If it gets less than positive 0.7 volts, the transistor acts like an open key. Therefore in the circuit, darkness around the LDR makes transistor act like a closed key, and therefore LEDs are on. And when there is light around the LDR, the transistor acts like an open key, and LEDs are off. So we finally reached our goal. The circuit works perfectly.